right, hey y'all, Mr. Kyle, Myers Mathematics, and let's just jump back into it. I'm going to do the second half of this worksheet on the properties of exponents. This is part of a series on infinite algebra 1, whatever that means. But algebra 1 stiff, algebra 1 worksheets, all the worksheets that are on Kuta Software's website for algebra 1, which are mainly intended to help you with if you are, working on some homework in Algebra 1 and you need some worksheets to look at and how to solve each question, not just the answers, which are, already one Google search away anyways, as you can see here, but also to have the solutions and the explanations. There's already some stuff up on the board. If you didn't see the first half of this video, I'll have that link in the description below, so go check that out. But also, we're going to be doing the second half. So if you missed the first half, videos down below. Second half is what we're going to be doing today. Here's some of what we did last time. And here's the next up section. Okie doke. So starting off with 17 here, we're going to need to take this to the negative 1 power. One thing about when they say simplify, when they say simplify, they mean that they don't want negative powers. Sometimes they'll say that, and sometimes they won't, but they don't usually want you to have your answer with any negative powers in it. So I would not normally do that unless the teacher specifically told you to leave exponents in the negatives. I don't think that would happen. That's what you want to do. You want to have your exponents or your powers in positives. So when I say something's to the negative 1 power, though, what that means is I'm going to flip it. So like if I say x to the negative 1 power, then that's going to flip and be 1 over x to the 1 power still. Or let's say it was already 1 over x, so 1 over x to the negative 1 power. All right, well then that would be x to the 1 power over 1, because it's, you could still write it as a fraction, but you don't need to write it as a fraction anymore because it's over 1. So one way to think about it is that it flips it. Another way to think about the negative power is that it will move it. If you already have a fraction established, then it moves what you have from the numerator to the denominator or the denominator to the numerator. So in this case, we want to think about flipping it because we don't already have a fraction. If we flip 2b4, it's 1 over 2b4. So that's it. All right, 18. We're going to distribute the 2 this time because one of these powers inside of here is negative, the other one's not. So it does matter to individualize it a little bit, whereas with 17, they were both already positive, so we just need to flip both of them. But we do want to distribute the 2. You can distribute powers. You can distribute them into anything being times or divided. Be really careful with that. You don't want to distribute into plus and minus. So then that's going to be x squared to the second power times y to the negative 1 to the second power. When I have a power raised to a power, it means I'm going to double it. Except it's not. Kind of. Doubling in the like actual sense of doubling is a no. But we are going to have double the amount of x squared. So I'm going to have x squared times x squared. X squared squared means x squared times x squared. Well, what's x squared times x squared? It would be x times x times x times x, which is x to the 4th power. So when you have a power to a power, you multiply the powers. We're going to do the same thing here. We're going to multiply those. So negative 1 times 2 is negative 2. And then we want to flip just the y. So here's where thinking of it maybe in terms of like flipping or versus from the numerator to the denominator is helpful because we want to keep the x to the 4th in the numerator because that's positive, so that's fine there. But the y we want to move to the denominator. All right, there we go. Now this one is a negative 1. It's applying to the whole thing, so we would flip the whole thing. You can, for number 19, flip the whole thing, but the y has a negative power as well, so it might be more helpful to just distribute the negative 1. Might be. Let's see. So this would be like that, like that. We're going to distribute it. So it's 2 to the negative 1 times x to the 4th to the negative 1 times y to the negative 3rd to the negative 1. Power to a power you multiply. Or in this case, 2 to the negative 1 power, that's going to be just flipped, because I don't need to do anything with that really. So that's going to be just 1 over 2. And then this would be x to the negative 4 power. And then this would be y to the positive 3 power, because it's negative 3 times negative 1, which is positive 3. And then we still need to flip the x, because all I did was just take the power to the power. So I still need to flip the x, but the y would stay. So it would be y cubed over 2 x to the 4th. All right, that was a little confusing, so I'll go over that again. We distributed the negative 1. Then if you have a power to a power that you need to do, then you do that. We didn't with the 2, so I went ahead and switched that up into a fraction right away. But with the other ones, I needed to do a power to a power. So for the x, I did 4 times negative 1. For the y, I did negative 3 times negative 1 is positive 3. Okay, so then I've got a 1 in the numerator, since I flipped the 2 down. So as far as like significant things in the numerator and the denominator, I've got an x to the negative 4th and a y to the 3rd. But x to the negative 4th in the numerator means I need to flip it. I need to flip it, change it to a denominator. So it's x to the 4th in the denominator now, where the 2 already went, because I had to flip the 2 as well. So I had to flip the 2 and the x. Both of them had negative powers. The y had a positive power, so it stays up in the numerator. All right, so now let's look at what happens if I do it where I flip it first. So I flip it first, like that. And then I would distribute the 2. So then that's 1 over 3 squared times m squared. And then evaluate anything if I need to. 3 squared is 9, so that's 1 over 9m squared. Here we go. Oh, I forgot to box these other ones. Here we go, here we go, here we go. All right, let's switch to a different color. Green. Go. If I can. Why does it not want to do that? It never wants to switch back. There we go. Okay. So for 21, we've got a little bit of simplifying to do actually, because we've got r's on the top and r's on the bottom. So remember when we're dividing. So far we've done power to a power and power times a power. Well, actually, just power to a power, really. Power to a power, you multiply. But if we're dividing a power and a power, then we actually subtract the powers. So this would be r2 minus 2 minus 3, basically. So the r2 part, if I just focus on the r2 part, this is the same thing as r to the 2 minus 3 power, which is r to the negative 1, which is 1 over r. Okay, so that's just focusing on the r's. Because it's r2 over r3, I'm going to be subtracting. So 2 minus 3, which is negative 1, and then I would flip it so that it's 1 over r. And then the 2 is already down there, so I just need to incorporate it with that. So it'd be 1 over 2r. So 1 over 2r is the answer. The other thing you can do is you can subtract the other way around, where you do r3 minus 3 minus 2 instead of 2 minus 3, and then leave the answer in the denominator. You can do that as well. It's a little more complicated to do that way, but it's faster, so I like it personally. What else? Oh, so the reason why we would be doing power minus a power is because r2 or r squared means r times r, right? And then so r cubed means r times r times r. Any number divided by itself is 1. It cancels. So that number, whatever r is, let's say it's 3. Well, that would be 3 over 3, which is 1. And then 3 over 3, which is 1 again. So you can cancel them out 1 for 1. So what's left over is going to be the difference. The difference in power is what's left over after you're done slashing, aka subtract, difference or subtract. So that's what happened there. All right, 22, we're going to need to flip the x. You can go ahead and subtract now if you want. So one way to do it would be to go and say, okay, so x negative 1, x to the 4th. That's going to be x to the negative 1 minus 4. which is x to the negative 5, which is 1 over x to the 5th. That's one way to do it. So doing it exactly like we did on 21. The other way to do it would be to flip it first because it's negative. Oh, and then by the way, you'd incorporate the 4 back in, so it would be 1 over 4x to the 5th. So that's one way to do it. The other way to do it would be to flip it first. So 1 over 4x to the 4th times x to the 1st. Then you'd have power times a power, so you'd add the powers. Right? So then you'd have power times a power means you add the powers. So power times the power, you add the powers. And then once you have them added, then you would rewrite it into the answer, which would then be like that. So either way works. Whichever way you like better, try it both ways, and whichever one you like better, try it that way only for, I don't know, like 5 to 10 problems. And that way you can really get a feel for which one you like better. So that would be what I recommend there. Here, the 3's cancel. And just like how a 3 cancels with a 3, an n will cancel with an n. So that's going to be n to the 4 minus 3 power, which is n to the first power, which is just n. So n is the answer. Over here, it's literally the same thing on the top and the bottom. A fourth power of something divided by a fourth power of something. No matter what that number is for m, it's going to cancel with itself. Because you take a number to the fourth power, and if you divide it by a number to the fourth power, you're going to get the same thing. It's going to be the exact same thing. So this is the exact same thing here and here. So the answer is just 1/2. Do not say that the answer is 2. The 2 doesn't magically move up to the top because there's nothing there. There is something there. It's a 1. It's not like the void where it's going to like suck the 2 up into the numerator somehow because now there's nothing there. No, there's a 1. The placeholder is a 1 always. So be careful with that. I see that a lot. All right, and then we have the last, oh, I thought it was the last set of 4. We have 6 more, actually. So switch over to gold. Why does it not want to do that? Every time I try to click on this arrow now, it doesn't want to unclick the arrow. It's really annoying. All right, whatever. So with this one, let's see. So let's move it first. So 3. Actually, you know what? I kind of like the other way better. I kind of do. So let's do that. So we would say m to the negative 4 minus 3. So we're going to do power minus a power, which is m to the negative 7, which is 1 over m to the 7th. And then you just incorporate that with the 3. The 3 is on the top, so it's 3 over m to the 7th. And there you go. Okay, 26. They ramped it up by quite a bit here. But the 2 and the 3, nothing happens there because they're just big numbers and they don't have any terms in common, so that's it for those. But we can take each one individually one at a time. Here, for the x's, let's say, we would do x to the 4 minus 2, which is x to the 2nd power. And then that's it, right? So that's x squared over 1. That's in the numerator. Okay, what about with the y's? Well, it'd be y to the negative 4. Careful, minus a negative 3. It's minusing, but the denominator power is negative, so it's minus a negative 3. That's y to the negative 4 plus 3. Two negatives right next to each other cancel and make a positive. Almost said a plositive. I'm almost plositive. All right, so y is equal to negative 1. Or sorry, y to the negative 1 power, which is 1 over y to the first power. All right, then we've got a z. So then it's z to the negative 3 minus 4, which is z to the negative 7, which is 1 over z to the 7th. All right, let's put all of that together. So we've got a 2 on the top. What else? For the x's, we do have an x on the top. It's x squared. Right? Okay, then what's on the bottom? Well, on the bottom, we've got a 3. And then what else? I've got a y on the bottom and a z to the 7th power on the bottom. And there we go. Whew. There it is. One bite at a time. It's exactly how you eat an elephant. One bite at a time. So 4 and 4 cancel. And then we just have some x's there. So it's x to the 0. You could say 0 minus 1 if you want, which is negative 1, which is 1 over x. Or the other thing you could do is you could say, okay, well, anything to the 0 power is 1, so you could just cancel it. And that works as well. So it just cancels. It doesn't cancel with something else, but it just cancels because I'm timesing it by a bunch of other stuff. X to the 0 power, any number to the 0 power is 1. So it just kind of goes away, just kind of cancels. Or you could say it's 1 over x, because 0 minus 1 is negative 1. X to the negative 1 is 1 over x, but there already was an x down in the bottom, so either way, whichever way you like better. And then put it all back together. Oh, just kidding, because we have a y to the negative 2. So that's the same thing as 1 over y squared. Now let's put it all together. Okay, so there's pretty much just a z on the top left over, z3. On the bottom, we've got an x, and we also have a y squared. There we go. All right, over here, same thing, different letters and numbers. There's no h's on the bottom, and this h is a positive power, so we don't have to really deal with that. But the j's, let's see, so negative 3 minus, if you don't see a power, remember it's a 1, not a 0. If you don't see a power, then it's a 1, right? Sometimes if you don't see a number, it can be something other than 1, but 1 is like by far the most common thing where it's like, okay, if you don't see the number, it's 1. The only exceptions to that would be like a square root. A square root is actually a second root, so there's like an invisible 2. Or let's say a logarithm. Logarithm would be a base 10, so that's a missing 10. If you're adding or subtracting nothing, then that would be the same thing as 0. So sometimes 0 could be a missing number. And that's all the ones I can think of. If you can think of any other ones, let me know, any other ninja numbers. But 1 is by far the best ninja of them all because it shows up or doesn't show up the most often. It's hiding in the shadows. So if you don't see a power, it's a power of 1. J to the 1, k to the 1. So this is negative 3 minus 1, which is j to the negative 4, which is 1 over j4. All right, and then we've got some k's as well. So then that's k to the 4 minus 1, which is k to the 3, which is going to be in the numerator. So good to go there. So then it's going to be 2 h to the third. The j's I consolidated. J's in the denominator, so that's not going to be up there. And then the k's I consolidated as well. There's a k3 in the numerator. What's on the bottom? Okay, well, there's a 3. The j's I consolidated, and it's a j4. And the k's I did as well, but the k's are up top. So there we go. And we'll switch colors one more time. I like to do pretty much every other or so. But you know what? It's like an orange. Let's do a red-orange kind of color, because otherwise it looks very, very similar to the gold that I'm using here. Okay, here we go. So 4 in the top. I'm going to speed run this one. Just let me know if you wanted to see how this would actually work out. But I'll speed run it. I'll say what I'm going to do in my head, but I'm only going to do some of the stuff in my head that I've been showing you out loud. So that's m to the 4 minus 2 is 2. 3 minus 2 is 1. P3 and P4, so there's more powers of P on the bottom, so the P is going to be on the bottom. Then I have a 3, and then I have a P1, because there's one more power of P on the bottom than on the top. So there you go. And then for this one, 3 on the top, no numbers on the bottom for that to combine with. 3 minus a negative 4 is a positive 7. Negative 1 minus a 0, remember zeros cancel. So that's just going to make the y and the z go to the bottom. What's on the bottom? Well, it did have an x to the negative 4, but that moved up to the top there. And then we have a y and a z, because they're negative 1 powers, so they're going to move to the bottom. But if they're moving to the bottom, they're positive 1 power. We don't need to show a positive 1 power. Ninja powers. And there you go. So that's it. If this has been helpful, go check out other stuff on my website, myersmathematics.com. You can always like and subscribe and do all that kind of stuff as well. But go check out all the resources I've got over there. I'm going to be trying to add lots and lots of stuff as of the time of this video. It is summer, so time to get on some of the more back-end kind of stuff and really really beef up the kind of stuff and the kind of resources that you can find on my website, myersmathematics.com. So go check that out. Some of it's free, some of it is not, just because I think it's valuable enough that I would put it all together. It's usually just if it's like an entire course on something. If it's just a snippet of something, that's pretty much always going to be free. Like, I'm not going to charge for like one little snippet of something that's really, really helpful or valuable, like a worksheet like this, So like all these worksheets or whatever, they're just little snippets. Those will pretty much always be free, as far as I can tell. But if it's like an entire course on something, like if you're looking for an entire course on Algebra 1 or an entire course on preparing for the SAT, all that kind of stuff, some of that will be like paid stuff. But I've got tons and tons of both on the website and more I try to add every week. So go check it out. And that's it for today. Have a blessed day, and I'll see you again in the next video.